So the angle between the north axis and then the east is 90. So if this is 30 degrees, then the angle between the two displacements, becomes 60 degrees. Okay. So we are to determine find the resultant displacement and the direction. And here I was expecting that you use the cosine rule. Some of you use resolution of vectors. Please, we will treat this, okay, from Thursday. So I just wanted you to be conversant with the method that had been taught. And so I was surprised you were using different methods. And to some of you, the method of resolution of vectors wasn't also accurate. Okay, please master whatever I'm taking you through. Would actually spend time to go through that resolution of vectors as well. I don't know if you have treated resolution of vectors in mathematics. Have you? Have you treated that in mathematics? Class, I'm asking those of you who use the method. So the resultant force therefore becomes, drawing a vector, we are resolving this into a parallelogram. So the resultant force, when you realign their directions, will be along the diagonal from the common point. And we've done this. So this becomes the resultant. Okay. So using the cosine rule, the cosine rule says that if you resolve it into this, then the resultant, the square of the resultant will be equal to the square of the first displacement, the second displacement, plus 2 times d1, d2, times cosine of the angle of separation between the two. So r squared would be equal to 10 squared plus another 10 squared plus 2 times 10 times 10 times cosine of the angle between the two displacements, which is 60. This is 100 plus another 100, because 60 is half. So we have plus 2 times 100 times half. Either half in fraction or 0.5 in decimal. Okay, this gives us 300. Therefore, the resultant is equal to the square root of 300. And this is 10 root of 3. 10 root of 3 is, I think, 17 point something kilometer. So this becomes the resultant displacement. If you also want to use the corresponding obtuse angle, the corresponding obtuse angle is 180 minus 60. Okay, so that becomes r squared is equal to 10 squared plus another 10 squared, this time minus 2 times 10 times another 10 times cos of 120. Since cos 120 is negative half, the value is the same. When you sum everything up, you have 300. So that, Gideon, I'm coming, so that your resultant is still equal to square root of 300, which is 10 root 3. Hey, Gideon, what's the question?
Yeah, please. You're supposed to get 200.
Come again.
Yeah, please, you're supposed to get 200.
No, cos 60 is half. Okay, cos 60 is half. So 2 times 10 times 10, half will cancel out. This is it. So you're supposed to get 300, not 200. So check it again. Frank, your hand was up.
Sorry, was a mistake.
Okay. Now the direction. The direction. The direction the resultant makes with the east or the north. Assuming that is alpha. When you use cosine rule, sine of alpha divided by 10 kilometers. Okay, the side opposite to the angle must be equal to the sine of the other known angle, 120, divided by the resultant, R. And we found the resultant, so we can use that. So this is equal to sine of 120 divided by resultant, which is also 10 root 3, or its decimal value. We then make sine alpha the subject. You have 10 times sine of 120 degree, all divided by 10 root of 3. Okay. Here's Godfrey. Godfrey.
Sir, please, why are we using
Why are we using
sine?
Oh, because we are using the sine rule. The cosine rule is for determining the resultant, and the sine rule is used to determine the direction of the resultant or any of the vector quantities. Okay. So we are using the sine rule, because we are looking for the direction. All right. Sine 120 is equal to sine 60. And sine 60 is sine 120 is root 3 on 2. Root of 3 on 2 times root of 3 divided by root 3 times root 3 is 3. Please, here it's just a calculation thing. Don't worry about what I'm doing. I am using this because I'm not using calculator. So we have 3 divided by 2 times 3 is 6, giving us 1 on 2. Therefore, alpha is equal to the sine inverse of half, which is 0.5. And this is equal to 30 degrees. Okay. So using the sine rule, this must be the resultant displacement and then the direction. And you can also use resolving this into triangle. Yes, which I taught last time. Some of you actually use it. So there are actually a lot of ways to use in solving problem. Please, is there any question? Anything you are not so clear about? So I explain before we continue. All right. Once there is silence, I'm sure all is well. Then the Easter challenge. Emelda. Hello. The Easter challenge. Two concurrent forces acting at a point make angles of 25 degrees and 65 degrees respectively with their resultants, which is of magnitude 15 Newton. And concurrent forces are forces that act at a point or on a body at the same time. They are simultaneous forces. Let me check on your message. Okay. All right. So now you are told that the two forces individually makes an angle of 25 and 65 with the horizontal, with their resultant. So let's represent this, okay, on the Cartesian plane, XY axis, or the north, northwest, north south, okay, west east axis. Now the choice is mine. I want to let the first force lie on the x-axis, positive or the east axis. So this is my first force, F1. I can also choose my first or second force to lie on the north axis. The choice is yours. So if F1 lies on the x-axis, then the angle between F1 and the resultant must be 25. So once I locate F1, to locate the resultant, I must measure an angle of 25 degrees from F1. Because the question says that it makes an angle of 25 with the resultant. So it means that this line must be my resultant. And the angle between F1 and what I'm denoting as my resultant must be 25 degrees. Then the same resultant also makes an angle of 65 degrees with another force, the other force F2. So an angle of 65 degrees from the resultant must also locate F2, meaning F2 is here. That's a 65 degree. So this is the resultant, which is equal to 15 Newton. That's how it must be done. Okay. F1 makes an angle of 25 with the resultant. F2 also makes an angle of 65 with the resultant. Now we have the resultant, we have the various angles. And the interesting thing is that look at the angle between the two forces. 25, 65, meaning the whole angle between the two forces is equal to 90. It's equal to 90. And once the angle between them is 90, we can resolve it into rectangular component and find whatever we are looking for. Meaning that the direction, if we draw the two forces to represent a triangle, an equal vector here, another equal vector here. Let's indicate the directions. This is all F1. Then this is also F2. Because the whole angle here is 90, it means the angle between F1 and F2 must be 90. And so we can say that the square of the resultant must be equal to F1 squared plus F2 squared. We have the resultant, which is 15. So 15 squared is equal to F1 squared plus F2 squared. And this is equation 1. Okay. Then the other choice is that once we have these angles, when we take the cosine of the angle 25 degrees, it will be equal to F1 over the resultant, which is 15. So this can help us find F1. F1 therefore is equal to 15 times cos of 25. And it will give you F1. You can also even use, without using equation 1, you can also take sine of the same angle. Sine of 25, which will be F2 over 15, the resultant. And you can, so there are lots of ways to actually use in solving this problem. You can also use the sine rule. You can use the sine rule. Okay, sine of, when you take sine of 25 over F2, this must be equal to sine of, this is 90. So sine of 90 over the resultant 15. And this will also help you find F2. So after the whole challenge with this question is your ability to draw. That is all. That is all. Please, if you have any question, quickly ask. Is there any question?
Sir,
Hello, Amelda.
it doesn't mean there are. I don't understand the sine, cos. Yeah, how you were able to derive the formulas for the sine and cos.
Oh, Amelda, sine of an angle. Sine of an angle is the ratio of the opposite side of the right angle triangle to the hypotenuse. So the angle in question here in consideration is 25. So if I take sine of 25, sine is the ratio of the opposite side of the right angle triangle to the hypotenuse. This is the opposite side, okay? The side of this, which is opposite to the angle. So F2. The hypotenuse is the resultant force, R. So that's how come I could deduce that sine of 25 is F2 over the hypotenuse, which is 15. On the other hand, cosine of the same angle. Cos of an angle is the ratio of the adjacent to the hypotenuse. The angle in question is 25. Don't forget, we can also use the 65 and we'll get the same result. So cos 25 is the adjacent. The adjacent to this angle is the horizontal side of the right angle triangle, which is F1 over the hypotenuse, which is the resultant, 15. So Imelda, I think you try and then understand the trig ratios, tangent cosine, and then sine. Is that okay?
Yes, please.
Okay, Saki, Giovanni.
Sir, please, why is it sine 25?
I can also use 65, and I'm using sine because either I'm using sine and cosine because either I'm looking for the opposite or the adjacent, and I have the hypotenuse, so I cannot use tan. Because tangent is about it's a ratio of the opposite side to the adjacent. But in this particular question, I have the hypotenuse, so that's why I'm using sine and cosine. But as for the angle, I can use 25, I can use 65, and the value will be the same.
Sir, please, F2.
Come again.
Sir, please, but F2 is 65 degrees.
What I'm saying is that we are looking at the angle the resultant makes with any of the forces, F1 and F2. That is why I'm saying I can also use F2, 65. Look at something. Assuming we are using the angle 65, and I'm looking for F2, which if we are using 65 and we are looking for F2, which appropriate trig ratio do we take? Must we take sine or cosine, class? Must it be sine or cosine if the angle is 65? I want to pick your views. If we are to use the angle 65 and I'm looking for F2, would I use sine or cosine?
Pardon?
Class, please, it's a question to all of you. Assuming we are using the angle 65 and I'm looking for F2, do we have to use sine or cosine?
Cosine.
So it is because you have to use cosine because F2 becomes the adjacent to the angle 65. So if I take cos of 65 degrees, adjacent over the hypotenuse, which is 15. Don't forget the adjacent is F2. F2 would be equal to 15 cos 65. Okay. And this will be the same as 15 sine 25. 15 cos 65 is equal to 15 sine 25. Check and then let's confirm for me. Input these values and then confirm for me. $15 times the cosine of 65 and then 15 times the sine of 25. Giovanni, what's the answer?
Sir,
6.339.
So are you getting the same answers for both?
yes,
Anita?
please.
Exactly. So that's why I said you can use 65 or 25 and you get the same results. All
Sir,
right.
please, another question.
Okay.
Sir, please, how did you get the sine 25 over F2 is equal to sine 90 over 15?
Sine rule. The sine rule that if you have any triangle, the ratio of the sine of their interior angles to their sides. So if this is the angle theta, then if I take sine of theta and then divide it by the side of the triangle which is opposite to the angle. So if theta, the side opposite to it is F2. So divided by F2 must be equal to the sine of any other available angle. And the available angle here is 90. So sine of 90 divided by the side opposite to it. And that is the resultant, which is 15. This is also equal to the sine of the other remaining angle. Okay. So example, if this is 25 and this is 90, what will be the other angle? If this is 25, this is 90, what will be the other remaining angle? Obviously, it must be 65. So this must also be equal to sine of 65 divided by F1. So Giovanni, this is the sine rule. Are you okay?
Sir.
All right. Let me check on your messages. Emelda, are you okay?
Yes, please.
All right. Now, before we look at resolution of, before we look at resolution of forces, you see, in dealing with vectors or consideration of vectors, we look at when two vectors are parallel, what is the angle between them? When two vector quantities are parallel, what is the angle between them? Pardon? Class, I'm listening. When two vectors are parallel, and just go ahead. If you know it, just
0 degrees.
go. So these are two parallel forces, F1 and F2. And because they are parallel, theta is equal to 0 degree. And we saw that the resultant vector or the resultant force will be the summation of all the forces. So F1 plus F2. When two vector quantities are opposing each other, are oppositely directed, what is the angle between them? When two vectors are opposing one another, what's the angle between them?
180 degrees.
Good. So this is F1, this is F2. And theta, the angle between them is equal to 180 degrees. The resultant is equal to F1 minus F2 on condition that F1 is greater than F2. The direction of the resultant is always the direction of the larger force. Then we also considered when they are perpendicular. When the two vector quantities or forces are perpendicular to one another, we are reviewing. And when they are perpendicular, the angle between them is 90. So F1, F2, and we just saw that, Frank,
Please, if the lines are perpendicular, does that always mean it's 90 degrees?
come again.
Like if the vectors are perpendicular, does that mean it's always 90 degrees?
Exactly. The word perpendicular means that it creates, the two create an angle of 90. Okay.
Yes, sir.
Or if the word perpendicular is not used, the other word that can be used is that they are normally to one another. Normally to one another. So under this situation, the resultant will lie along the diagonal. Whether this is triangle law of vector, it will lie along the diagonal. And we also saw that under this condition, the square of the resultant will be equal to the square of the summation of the squares of the forces or of the vector quantities. Then when it is at any angle theta, whether obtuse or acute, we are reviewing, so please pay attention. When the vector quantities are inclined to one another, okay, in such a way that the angle of inclination is acute or obtuse. Barak, please mute yourself. Barak. Mute yourself for me. So in my illustration, theta here is acute. And the concept is that if you have this situation, resolve the two forces or vector quantities so that they form the opposite sides of a parallelogram. Resolve them into a parallelogram. Resolve them into a parallelogram of forces. And once that is done, the resultant is drawing a line from their common, a diagonal from their common points. And this one also obeys, yes, the triangle law of the parallelogram law also obeys the triangle law of vector addition after doing that. So F1, F2, and the resultant R, the square of it, is equal to F1 squared plus F2 squared plus 2F1 times F2 times cosine of the angle separating the forces, or the corresponding obtuse angle is 180 minus theta. And so R squared is also equal to F1 squared plus F2 squared minus 2F1 times F2 times the cosine of the corresponding obtuse angle. Marilyn, please mute yourself for me. Now, the good news is this. The sine rule, the cosine rule, which can be 1 or 2, is a super rule which can be applied to all the directions, whether it's theta, whether it's 180, or whether theta is 90. The sine rule or the cosine rule is a super rule which can be used to solve all these. Now, let's see how we can use the the cosine rule when the two forces are parallel. When the two forces are parallel, theta is 0. Sidel, please mute yourself. Okay, when the two forces are parallel, theta is 0. Let's substitute the angle 0 in place of theta. So you have r squared is equal to f1 squared plus f2 squared plus 2f1 f2 times cos of 0. Class, what is cos 0? What is cos 0?
1.
Cos 0 is 1. So you have r squared equal to f1 squared plus f2 squared plus 2f1 times f2. Now, class, if you have, help me expand f1 plus f2 all squared. Help me expand f1 plus f2 all squared.
f1 squared plus f2 squared.
Are you done? f1 plus f2. Nana Kwenchiwa.
Sir, please, f1 squared plus 2f1 f2 plus f2 squared.
Yes. So it means that, you see, what we have at the right-hand side, we can equate it to f1 plus f2 all squared, isn't it? Class, isn't it?
Yes, please.
Good. Help me find r, not r squared. Help me find r. How do we find r? Yeah, it's fine.
Square both sides.
Good.
Find the root
So
of
what?
both sides.
Exactly. So when we square both sides of the equation, we have r equal to f1 plus f2, isn't it? So it brings us back to what we stated here, that when you have two forces in parallel, the resultant is the summation of all forces. So we've used the cosine rule to prove or derive the same thing we earlier talked about. Please, is it understood? Anita, Sidel, Anna, and the rest of you. Are you okay?
Yes,
please.
All right. Now, when the angle separating them is 180, when theta is 180, okay, let's first consider when theta is 90. When theta is 90, and then use the cosine rule to obtain a solution for it. So here we substitute 90 for theta. So we have r squared equal to f1 squared plus f2 squared plus 2f1 f2 cos of 90. Plus, what is cos 90?
0.
0.
Go, 0. So it brings us to f1 squared plus f2 squared because 90 is 0. So that part goes to 0. So r therefore will be equal to the square root of f1 squared plus f2 squared. So we are using the cosine rule also to prove this. The same thing. Can you try it for when theta is 180? I want you to try it for when theta is 180. (180) degree. I'm waiting for you. So I'm taking note of attendance. So do that whilst I also do that. Okay.
Giovanni,
Simplicity, we go to the square root of f1 squared plus f2 squared minus 2f1 and f2.
So simplify it. I just want the simplification. Anita and who I miss one. Frank. Oscar.
okay. So,
All right. So if theta is 180, we have r squared f1 squared plus f2 squared plus 2f1 f2 cos of 180 degree. Theta is 180. Now what is cos 180?
-1.
That's -1. So we have minus 2f1 f2. Class, what is f1 squared plus f2 squared minus 2f1 f2. What is it? Can somebody give me an expression which will represent this? Can somebody give me an expression which will be equal to f1 squared plus f2 squared minus 2f1 times f2? Okay. If you are not figuring that out, I want you to help me expand this. Help me expand f1 minus f2 all squared. Help me expand this. f1 squared minus f2, f1 minus f2 all squared. There. Rempoma and Co. I'm listening. Help me expand f1 minus f2 all squared into bracket all squared. Yeah, it's Giovanni.
Sir, please f1. Sir, please f1 squared minus 2f1 f2 plus f2 squared.
Okay. So when you rearrange, you have f1 squared plus f2 squared minus 2f1 f2. You see, we can equate the right-hand side of what I have put into the rectangle. We can equate the right-hand side to f1 minus f2 all squared. So r squared is equal to f1 minus f2 into bracket all squared, since the expansion is equal to it. Giovanni.
Then please, can you go back to the previous page? I want to see the what you got for the when we use theta.
When I use theta is equal to 190,
Yes, sir.
we had the same thing as using Pythagoras theorem. Are you okay?
Yes, sir.
Okay. So, since whatever we have within the bracket is equal to this, then R can be equal to F1 minus F2. This is on condition that F1 is greater than F2. All that I'm trying to draw your attention to is that the cosine rule is a super rule which applies to all angles, whether parallel, opposite, perpendicular, acute, or obtuse. Class, is that okay?
Yes, please.
All right. Okay. Now let's look at negative vectors. Negative vectors. Negative vectors are not different from positive vectors. The difference only has to do with their direction. So if I draw a vector, A, the magnitude of this vector is from its starting point to this point. Because it's a vector quantity, there must be a direction. The negative, so this is the vector A. The negative vector of this same positive vector can also be obtained by drawing the same length as the magnitude. So the magnitude is from this point to this point. But reversing the direction, this is due east. If I reverse the direction to west, it is the negative of the vector A. So negative vector has the same magnitude as a positive vector, but its direction is opposite. Okay, and we use negative vectors a lot in physics, especially when we are looking at for relative velocity. I think we will treat relative velocity and vectors. Then it is also used in the difference between velocities, difference in velocities. If we have a body moving with a velocity A and another body with a velocity B, if we want to compare the velocity of the body A to the velocity of the body B, that is when we talk about relative velocity. So the relative velocity of V of A, B is termed as the relative velocity of a body A with respect to B. Okay, which is written as VAB, meaning we are comparing the velocity of A to the velocity of a body B, and VAB is technically written as velocity of A minus the velocity of B. If it is the relative velocity of a body B with respect to A, then it is also the velocity of the first letter B minus the velocity of the second letter A. So this is one instance where we use negative velocity, meaning that to determine the velocity of A with respect to B, you must negate the velocity of B and add it to the positive velocity of A. That is basically what it means. So that is the idea of negative velocities. Okay. So in writing negative velocity, the negative velocity has the same magnitude as the positive velocity, but its direction is reversed. And we are going to apply this in solving questions under this concept. Please, if you have any problem, ask before we continue. I'm going to give you a question where we would apply the concept of relative velocity. Is there any question? Okay. Giovanni,
Sir, please, it's a mistake.
okay. Frank, I hope it's a mistake too. Okay, Davis, Ella.
Step.
Yeah, Ella.
Step, this will take you to explain again.
When we talk about negative velocity, okay, negative velocity has the same magnitude as positive velocity, but its direction is always reversed. Okay, so if a positive velocity has a magnitude of, let's say, 10 kilometers, and it is due east, the negative of that same velocity would also have the same magnitude as 10 kilometers, but its direction will be due west. So negative velocities have the same magnitude as the positive velocity, but their direction is always reversed. We reverse the direction of its positive velocity. Are you okay? Ella, are you okay?
Yes.
I want to give a question to that effect quickly, so we'll try our hands and then. So give me a second, I'm coming. Please, I'm coming in. Okay. Two vectors of equal magnitudes of 10 units. Two vectors of equal magnitudes of 10 units. An angle of 60 degrees between them. Okay, let me take it again. Two vectors A and B. Two vectors A and B of equal magnitudes of 10 units and angle of 60 degrees between them. And an angle of 60 degrees between them. Find the magnitude of I'm not out. I'm dictating, so you don't worry. Find the magnitude of I, A plus B. Find the magnitude of I, A plus B. And I, A minus B. So we are to find the magnitude of I, A plus B. And I, A minus B. Two vectors A and B of equal magnitude of 10 units, and an angle of 60 degrees between them. Find the magnitude of I, A plus B, and I, A minus B. Class, I want you to use 5 minutes to try I. The first question I, and I'll solve I with you. They have equal magnitudes, 10 units. Frank. Hello, Frank.
Please, can you repeat the question?
Two vectors A and B of equal magnitudes of 10 units. Two vectors A and B of equal magnitudes of 10 units and an angle of 60 degrees between them. And an angle of 60 degrees between them. Find the magnitude of I, A plus B. Find the magnitude of I, A plus B. And I, A minus B. Frank, this is the question. So 5 minutes to try the I question. Then we discuss the I.
Asida. Asida.
Hello.
Your
Your
correction
correction
never
never
got to
got.
me.
Eh?
I'm sending.
It's pending. Is Ishra home?
Yes, please.
Ask her to contact me after the class.
Okay.
Girlfriend,
Sir, please, I don't understand.
you are given two vectors, A and B. Okay. And we are told they have equal magnitudes, but the angle separating them is 60. So this is similar to you giving two forces F1 and F2, and being told that, okay, F1 is 10 units or 10 Newton, F2 is also 10 Newton, and the angle between F1 and F2 is 60. Find the resultant. Okay, so it's similar to all the examples we've solved. The only thing is that here the resultant is to be obtained using the triangle law of vector addition or the parallelogram law of vector addition. So we'll discuss it after the stipulated time. So don't worry. Okay.
Yes, sir.
I'll discuss both questions with you. You have 2 minutes to go. Are we through? With I. Hello. What did you make for A plus B? Hey, class, talk to me. Akosia, Alethea, Anita, Anna. And Rocco, Antoinette, Aseda, Augustine, Barak, Caleb, Daisy, Didier, Frank, Frempoma, Gerard, Gideon, Giovanni, Godfred, Asana, Isaac, Jacob, Yella, Jessica Johnson, Kingsley, Lodina, Marilyn again, Mary, Michaela, Fidel, Mouse, Nana, Kwame, Wentua, Nicole, Ohene, Oscar, Fadi, Imelda, Valerie, Yabukoa, Yasmin. Hey, Yasmin also here. And you are quiet, Janelle and Jean. Okay, so let's see. So the two vectors we are A and B are, in terms of magnitude, I'm coming. In terms of magnitude, the magnitude of A is equal to the magnitude of B. They are 10 units. The angle separating the two vectors, theta, we are told is 60. So let's draw them. Their choice is ours. Maybe along the X and then along the Y. Okay, what is important is that we are told the angle between the two vectors is 60. And we are not given any direction of order. So if I put one of them along the X, A, then before I can locate the other one, B, Godfred, are you paying attention? Godfred,
Yes, sir.
okay. Before I can locate the other one, B, I must measure an angle of 60. Then I locate B. So this is also B. And the angle separating them is 60 degrees. I can also choose to place my other vector on the y-axis. So two other possibilities. The other possibility is that I can choose to put B here along the y-axis. B, A is here. The choice is mine. Now, when I measure an angle of 60 from A, I locate the other vector B. So this is B. And the most important thing is that the angle separating A and B is 60. So how to draw it? There's no special order. You haven't been told how to draw it. All that you are told is that they have equal magnitude and the angle separating them is 60. Okay. 10 units. So this is how it must be. Now, before I can determine A and B, I must resolve this into a parallelogram. Because the angle is not equal to 90, I must resolve them, the vectors, into a parallelogram. And that's exactly what I'm doing. Anita, last time your parallelogram was scary. Anita, for your information. So same magnitude, same direction. Okay. So this is also A, whereas this is also B. Now look at the directions now. And so we can now pick the diagonal as a result and from parallelogram law of vector addition. So from that same common point, from that same common point, when you draw a diagonal, it represents the resultant. And obviously, the direction must go up. My diagonal is not well drawn. I don't want it to look like how Imelda will draw hers. It's still the same. Okay. So looking at the direction, obviously, the diagonal which represent the resultant must go up. Now, from the triangle law of vectors, okay, these are the two sides, and so we can say that by the direction, the resultant must be equal to the sum of A and B. So A plus B. So the resultant is actually equal to A plus B. And please, are you okay with what I've done so far? Giovanni?
Sir, please, is it equal to A plus B when it's a scale drawing or when it's on scale like this one?
We are only applying, you see, for scale drawing, yes, the sum of A and B must be 8. So we can represent the resultant as A plus B. But we cannot just add A and B to find the resultant, which is A plus B, because this is not drawn up to scale. Okay, but by their direction, by the aligned direction of A and B, we can now say that, oh, okay, the resultant is equal to the direction of A plus the direction of B. And this is the triangle law of vector addition. So this is what we actually call it as the resultant. Are you okay? Are you okay?
Sir, please, can you go over?
What I'm saying is that, yes, by the triangle law of vector addition, the resultant is equal to A plus B, okay, by their direction. But because this is unscaled, we cannot just sum A and B to find it. But by their direction, we can say that the direction of the resultant is equal to the direction of A plus the direction of B. Okay. Now, the next question is how to find this resultant, which is A and B, A plus B. And because this is unscaled drawing, we will use the cosine rule. So A plus B squared, same as the resultant squared, must be equal to A squared plus B squared plus 2 times A B times the cosine of the angle between them. Okay, and A is 10, B is 10 plus 2 times 10 times 10 times cos of 60 degrees. And this must be equal to 300, aka 10 root of 3 units. So A plus B is equal to this. Class, are we okay? Hello, are we okay here?
Yes, please.
Okay. So Godfred,
Yes, sir.
are you okay?
Yes, please.
Marilyn, are you there?
Yes, sir.
Are you better? Marilyn, are you okay?
So I'm trying to understand it, but I'm having difficulty understanding the things they are teaching.
Why? Is it network?
Pardon?
Is it network issue?
Yes, sir.
Okay, we are here to solve the other one, so pay attention. Gideon, your hand was up.
Please, can you go over again?
Okay, so I'm going over. So if you did not understand, please pay attention for the last time. Yasmin, are you there? So this is the drawing. Now, by realigning their directions, you can determine the resultant, okay, using the diagram law of vector addition. The resultant will be drawing a vector from the diagonal of their common points to this end. Okay. Now, by triangle law of vector addition, the resultant R must be equal to A plus B. So we can represent the resultant with A plus B. Okay. So their A plus B, as stated in the question, is actually a representation of the resultant. Now, because this is not a scale drawing, we can find this resultant, which is A plus B, using the cosine rule. And using the cosine rule, we saw that the square of the resultant is equal to the square of one side plus the square of the other side plus 2 times A times B times the cosine of the angle separating the two vectors. This is the cosine rule. Okay, so the value of A is given, value of B given, they have the same units or magnitude. So 10 squared plus 2 times A, which is 10, times B, which is also 10, times the cosine of the angle separating them. And this must give us 10 roots of 3 units. Don't forget, we can also use their corresponding acute angle. Since this angle here is also 60, it means that the angle here is 120 degrees. And A plus B squared would also be equal to A squared, which is 10, plus B squared, another 10, but minus 2 times A times B times cos of 120. And the value will be the same as 10 roots of 3 units. That's fine.
Sir, please, why didn't you leave your answer in decimals?
Oh, it's just a choice that I made. You can leave your answer in decimal. 17 point something. Okay.
Okay.
All right. Is there any other question? Okay, then let's review the second situation. The second question, I demands that we find the magnitude of A minus B. A minus B is equal to the vector A plus negating the vector B. The vector A plus negating the vector B. So it means that here, before we can find A minus B, we must negate the vector B. Okay, I must draw let me clear this and then produce a drawing to that. Okay, so the original drawing at the left-hand side, and then the vector A is along the x-axis, so this is A, 10 units. To locate B, we must draw an angle of 60 degrees from B, from A. So this is B. Ten units. The angle separating them is 60. Now, A minus B is equal to the vector A plus the negative of the vector B. So it means that to determine A minus B, I must negate B. And negation of B has to do with same magnitude as B, but reversing its direction. So my new B must have the same magnitude as the original B, which is from here to here. And so by negating the direction of this, I have minus B, which has the same magnitude as the positive B, but its direction is opposite to the original B. Please, if you have any question here, ask before I continue. If you have any question, so this is negative of B, the same magnitude as the positive, but the direction is negated or opposite. Giovanni.
So please, so for the question, the answer was 10 root 3.
Or 17 point something.
So
Are
if
you-
I thought you said we should find for A minus B or something like that.
That is I. I is what I'm discussing with you. For I, the answer is 10 root 3, A plus B. Are you okay?
Yes, sir.
Okay, so this is the negative of B. How do we find AB? We can find AB after realigning their direction, as we've been doing. Look at where A is going. Look at where negative B is going. Their directions are not orderly. So we can find A minus B after realigning their directions as we've always been doing. So let's resolve it so that their direction will follow a sense of order. So equal vector of A on the head of B. So I'm drawing an equal vector of A on the head of negative B, as we've always been doing. So it must have the same direction as A. We can also draw same for B, negative B. Same magnitude and same direction. Negative B is going downwards. And look at the directions now. Whichever way you want to look at it. A, then minus B downwards. Or minus B downwards, and then A horizontal. So from the realignment of the direction, we can see that the resultant will be drawing a vector from here to this point. So per the new direction, the resultant will act downwards. Okay. Now this also obeys the triangle law of vector addition, that negative B plus A must be equal to the resultant. So it's like if we have A must go horizontal and then negative B must go down, then the shortcut will be drawing a vector from the common points to the head of A, and that is okay. So this is the resultant, which is actually equal to A minus B. So after realigning their directions, the resultant is equal to A, the positive first, minus B, the negative. So the resultant, which is along the diagonal, is equal to A minus B. But you can do that after you have negated B. Please, is there any question? Frank?
So what if it's B minus A? Would the A be negated? The
Exactly. If it's B minus A, you must reverse the direction of A. So here we have reversed the direction of B because it is A minus B. That's just the rule. Are you okay? So this is the same thing as the resultant. This is the same thing as the resultant. So under this circumstance, how do we determine the resultant? The resultant can be obtained by cosine rule because we resolved it into a parallelogram. So A minus B squared is equal to A squared is equal to A squared plus, if you make it as negative B squared, a square of negative B is the same. Okay. So plus Giovanni, 2
Sir,
times.
please, I don't get how you got the A minus B. Like, why you change its direction? And you connected it back to the A.
We are realigning the direction of A and negative B because this is west, this is south, this is east. The direction of this is due southwest. The direction of A is due east. We don't know where they are going, so you want to give meaning to their directions. Hence, using what we've been doing as equal vectors approach. Draw equal vectors of both A and negative B. Okay, and after doing so, then you can, looking at the direction of A and B, you can tell that the resultant will be drawing a vector from the common points along the diagonal to this point. So it is the same as what we've been doing. The only difference is that here we must negate B to get that. Frank?
The minus B squared, won't it be B behind the 2A.
No, it is the square of this. The square of this minus B is the square of this. So it must be minus B into bracket all squared.
Okay, sir.
Now, what is the angle between A and minus B? What is the angle between A and minus B here? Please, what's the angle between A and minus B here?
150. 150.
Open your eyes. It's not 150. Open your eyes. What's this angle? Between
120.
A, it's 120.
120.
Yes. So plus 2AB times the cosine of that angle 120. 10 plus 10 plus 2 times. Please, let me correct something before. You see, this thing is about the magnitude of A squared plus the magnitude of B squared plus 2 times magnitude of A times magnitude of B times the cosine of the angle separating them, which is 120. Please, when we talk about magnitude, we mean the numerical value. So magnitude of A minus B squared is equal to, the magnitude of A is 10. The magnitude of B is 10. Magnitude, we are referring to numerical value, number, franc. So 10, and here we overlook the minus plus 2 times 10 times 10 times cosine of 120 degrees. So the cosine rule is the magnitude of the force or the vector. 10 squared, another 10 squared, this is 200. Cos 120 is equal to negative half. So you have plus 2 times 10 times 10 times negative half. Michelle, Deborah, this can also be negative 0.5. Okay. So please help me find the value of A minus B. Help me find the value of A minus B. The magnitude of A minus B.
100.
The final value. What is
100.
that? Come again.
100.
It's not 100. It's not 100. I'm not saying A minus B squared. Help me find the magnitude of A minus B.
So please 10.
The answer is 10 units. 10 units. Class, your work to the same question is this. I want you to help me find the magnitude of B minus A. Help me find B minus A. Start with B minus A. Augustine, is not negative 10 because, you see, we are talking about the magnitude, so numerical value. Of course, the negative b has, ideally is negative 10, but we are looking for the number, the square of the number. That is why I put a and b into this sign to indicate that numerical value. That is the meaning of magnitude. So the numerical value is 10 squared plus another 10 squared, not the negative 10. Because number, we are not interested in the negative. That is why it's not negative 10. But coincidentally, cos of the angle between them is equal to 120. So cos 120 is negative half. That is why we had negative positive 10. You are looking for the magnitude of b minus a. So here you must reverse a.
Sir, please, I don't understand why you got 10
Why I got what?
minutes
Your line is breaking.
for the
No, your line is breaking. You can test it to me. You can test your question to me. Frank, you had 10. Emelda, what have you had? Gerard.
So please, I had 10.
Okay, let's see. Anita. Quentua. Janelle. Everybody is quiet.
Yes, sir.
And what's your answer?
Certain.
Okay, let's see. So A is here. If I measure 60 from A, I locate B. This is B, 60. I'm looking for B minus A, meaning I must negate A. Same magnitude, opposite in direction. Okay. So minus A. Now, to get B minus A, I must realign their direction so that it follows that sense of orderliness. Okay, so I'll put B on the head of A so that both are parallel. direction of B as well. Their angle, this angle will be equal to the 60. I can also do same for minus A. So this is also minus A. Now, minus A in this direction, B in this direction, or from here to here, it's obvious the resultant would go up. So this becomes the resultant, which will be equal to B minus A. Okay, B minus A. If I'm to determine their magnitude, A, B minus A, yeah, Gideon.
So, please, I was saying, I don't understand why you got the 10 units for the A minus B.
How I got what?
The 10 units. So, because when I check, it's not supposed to be 10 units.
And the square of A plus the square of the magnitude, number, value, please. So B seems minus 10, but we use the numerical value and ignore the negative. So 10 squared plus another 10 squared plus 2 times 10 times. Do not bring because it's magnitude. Magnitude refers to the absolute value, number. Are you okay? Times the cosine of the angle between them, which is 120. So B minus A squared becomes 10 squared, the same rule, plus 10 squared. Here we are using the angle between them. So plus the angle between A and B plus 2 times 10 times 10 times the cosine of the angle 60. We have 100. Giovanni.
Why isn't it minus 2 times 10 but plus?
Because we are using the angle between A and B. Minus A and B. We realign the directions to have minus A plus B, giving us B minus A. So the question is that what is the angle between A and B? Here, what did we use? We use the angle between A minus B, and it is 120. Okay. After negating the direction of A, what is the angle between minus A, okay, and B? That is 60. Are you okay?
So, sir, what will you do before it become minus 2? Like the type of question will give you before it
Minus
become
2AB, when you use the corresponding obtuse angle, cos 180 minus theta, cos 180 minus theta is when it becomes negative. But if you are using the angle between the two vector quantities, it is plus. Go and watch the previous videos. I hinted on this. Okay. Hello. So So because I'm interested in the angle between minus A and B, and that's the question. The question is actually B minus A, okay? And this is the angle between the two vectors. So plus 2AB times the cosine of it. 100 plus 100 plus 200 times half. And that is 200 times half, this is 100. So you must get 10 root 3 units. 10 root 3 units. Please, are you okay? If, however, you want to use this angle, when you extend this line, when you extend that line, this angle here will be 120, which will be equal to this angle as well. So if you want to use the corresponding acute angle, obtuse angle, then you have minus 2AB times the cosine of 180 minus theta, which is 120. And this must also give you the same answer as if you have used this. Please, is there any question? It's already 12 o'clock. So if you have any question, quickly bring it. If you don't have any question, then we call it a day. Your assignment will follow, and then we continue on Thursday. All right. Okay, so this is where we end today. So please go over revision. Okay, go over the same thing, and once you spend time to revise, when you are given a similar question, you will be able to figure that out. All right, so bye-bye to all of you.